The emergency sleeping bag in your hand contains technology that was literally developed to keep humans alive in the vacuum of space. Today, I'm going to show you how aerospace engineering created the most effective survival tool ever made and why this space-age technology costs $12 instead of $12,000. NASA faced an impossible engineering challenge in the 1960s: create materials that could regulate temperature in an environment where traditional insulation doesn't work. Space has no atmosphere to conduct heat, no air to trap for insulation, and temperature swings from 250-degree arrive in sunlight to 250-degree arrive in shadow. The breakthrough came from understanding that in vacuum conditions, heat transfer happens almost entirely through radiation. Engineers developed ultra-thin materials with near-perfect reflective properties that could bounce thermal energy back to its source with minimal energy loss. These materials had to meet impossibly strict requirements: weigh almost nothing, fold into tiny spaces, work reliably in extreme conditions, and never fail because failure meant death. The margin for error in space applications is literally zero. When Apollo astronauts stepped onto the lunar surface, they were protected by the same reflective technology that now fits in your pocket. The materials that kept them alive in space now keep terrestrial humans alive when Earth's conditions become hostile. Military applications came next. Downed pilots needed emergency protection that worked in any climate, weighed nothing, took no space, and required no training to deploy. The same materials that protected astronauts from space now protected aircrew from enemy territory. The genius of this technology transfer is that space represents the ultimate worst-case scenario for thermal regulation. If materials work in vacuum conditions with 500-degree temperature swings, they'll work in any terrestrial emergency situation. But here's why this space technology costs $12 instead of thousands: mass production and material improvements. What once required specialized aerospace manufacturing now uses standard industrial processes. The same physics works at any production scale. The technology hasn't been dumbed down for civilian use. It's been optimized for mass production while maintaining the same performance characteristics that kept astronauts alive. You're getting aerospace-grade protection at consumer prices. Emergency sleeping bags represent successful technology transfer from the most demanding application possible to everyday civilian use. The materials that protected humans in the ultimate hostile environment now protect them in terrestrial emergencies. This explains why emergency sleeping bags outperform traditional camping gear. They were designed for conditions far more extreme than anything Earth can produce. When you're dealing with technology designed for space, terrestrial emergencies become manageable problems. The space program's investment in thermal management technology has created civilian benefits that continue saving lives decades later. Every person who survives exposure using an emergency sleeping bag benefits from billions of dollars in aerospace research and development. Technology transfer from extreme applications to everyday use creates tools that seem almost magical in their effectiveness. Emergency sleeping bags work so well because they were designed to solve impossible problems, making ordinary emergencies seem easy by comparison.